Hello, my name is Lang Wen, and this is my presentation over the factors affecting physiological functions. So, what are physiological functions? By definition, physiological functions are the biomechanical properties on how the body operates. This includes how the internal body systems work together simultaneously so that the body is able to move, think, and see. For instance, how the skin cools down the body when it has generated heat from exercise by sweating, or when the body tries to warm itself up by shivering when temperatures outside are cold. Factors affecting physiological functions during exercise. For enhancers, there's healthy dieting, the reticulating activating system, adequate hydration levels, and clothing/shoes. Dieting, it is a two-way street that can swing both ways. It is a big factor that can affect the physiological functions during exercise where nutrition is key. It can play the role of a limiter or an enhancer. Like the famous saying goes, you are what you eat. For the case as it plays as an enhancer, it will assist the body by providing a sufficient amount of energy so that the body is able to exercise. As for the reticulating activating system, uh, it's another enhancer that is a psychological factor. It is a group of neurons located in the stem of the brain where it communicates to the hypothalamus. The reticulating activating system helps determine whether a person can or cannot yield to a belief. In these circumstances, with exercise, it can be a contributor to how far the intensity and duration will be during exercise. As for hydration levels, they play an important role during physiological functions in exercise. Having an adequate amount of water can help provide the body with the correct amount of blood flow to allow the muscles to operate under stress. Now, when it comes to shoes, wearing the right type of shoes for whichever exercise performing is an enhancer for physiological functions. For example, when going out for a run, running shoes would be applicable in this case. Running shoes help provide the stability and cushion for that moment when your heel strikes the ground. And for clothing, wearing certain types has the ability to either establish a barrier for heat loss or delay heat exchange. Depending on the weather and temperature, clothing helps to enhance the physiological functions during exercise. Now to talk about the limiters. For limiters, we have weather temperatures that are too hot or too cold, altitude change, unhealthy dieting, and low hydration levels. Hot temperatures affect physiological functions by means of excessive water loss, reduced effectiveness of heat loss, and increased heart rate. During cold temperatures, body heat is used quickly to keep the body warm, and during this time, the body loses heat faster than it can be generated. This is difficult for the body because it is sending energy sources to different areas of the body in order to stay warm, as opposed to sending energy to areas of the body to work under stress. As for altitude change, the higher you go up, the less moisture and oxygen you'll have to work with in the air. This will cause your heart to work overtime in order to meet the demands of energy distribution. As I said before, nutrition is key. In the case for dieting being a limiter, it can cause a person to not have an adequate amount of energy for exercise. This can lead to a less driven motive to exercise and replace it with a sedentary lifestyle. For hydration levels, if they were low, it could slow down the blood flow and cause dizziness or lead a person towards fatigue quicker than usual. It is important to make sure before, during, and after exercise to receive the adequate amount of water, and it is usually based off the body weight and workout intensity. How rest affects physiological functions. When we hear the word rest, we tend to acknowledge the word by sitting down or laying back where we are doing nothing productive. That does not necessarily mean that our bodies are doing nothing internally. In actuality, our bodies are working in a manner so that our bodies can physiologically function normally. When our body is at rest, our cardiac output, blood flow, blood pressure, and oxygen extraction act accordingly. Cardiac output is measured in liters per minute and is a product of heart rate and stroke volume. When the body is at rest, it normally sits between 4 to 8 liters per minute and usually increases approximately 40 to 60% during exercise. With a lower heart rate and stroke volume, the blood flow, blood pressure, and oxygen extraction follow. At rest, the blood flow going through a human body receives about 20% from the cardiac output to operate normally, and during exercise, the cardiac output contributes to about 80%. As for the blood pressure, it only rises as much as the physical activity rises. When the body is at rest, the blood pressure ranges from 60 to 100 beats per minute and is followed by the oxygen extraction, which is usually between 4 to 5 milliliters of oxygen for every 100 milliliters of blood. Similarities between exercise and rest. A few similarities between the factors affecting physiological function during exercise and rest are the outside climate and dietary consumption. In hot weathers, it requires a higher oxygen uptake to rest or exercise when compared to a temperature that is thermoneutral. During cold weather situations, the body's ability to adapt to the hostile environment will display itself based on the fitness level of an individual, whether at rest or while exercising. Now, whether at rest or exercise, dietary consumption provides energy to maintain the normal physiological functions. Food is fuel, and the body is consistently moving in order to maintain homeostasis. Now, according to Catch V, McArdle, and Catch F, heat generated from oxygen uptake may raise temperatures to fever level, but does not cause heat dissipation failure. Whether it is in hot or cold temperatures, it is actually beneficial to the internal adjustments that generate heat from physical activity for physiological and metabolic functions. And that concludes my presentation. Here are my references, and thank you for listening.